Hello everyone and welcome to today's video, which should help you out on quite a few of the Hegarty tasks this week. So I've actually got up on the screen a bell task which I would like you to actually have a go at right now at home. So pause the video, have a go at these 4 questions, and then when you're ready to resume the video I'll go through the answers. So I'll give you a couple of seconds to pause the video. Right, just going to close the door and we'll get started answering these questions. So I'm really hopeful that you actually gave these a go. It's much better if you do and you don't just wait to see the answer. Of course, if you've forgotten what to do, you might watch me answer the first one and then pause the video and then try the rest. So you can always do this. You can pause the video at any time. You can go back at any time. Just do what is right for you. So, number 1. So we've got a part A, which is the median, and we've also got a part B, which is the interquartile range. So, just a couple of reminders. You're always going to need to put the numbers in order whenever you're doing anything to do with the median and anything to do with quartiles. So let's do that first of all. So let's put these numbers in order. So it goes 2, then 3, then 3, then 7, then 10, then 12. Okay, so you put the numbers in order. Got to do that. And then to actually work, so if I just start by talking about part B, just really briefly, to actually work out the quartiles, you need to make sure that you've worked out the median. So to actually do part B, you need to do part A anyway. So let's do part A. So for the median, of course, you go to the middle. So I would cross off that one, cross off that one, cross off that one, cross off that one, and now I'm left with 2 in the middle. And whenever you're left with 2 in the middle, you go halfway between them, and in order to do that you can add them up and then divide that answer by 2. So 3 add 7 is 10, and half of 10 is 5. So halfway between 3 and 7 is of course 5. So the part A answer is that the median is 5. Now for part B, remember what the interquartile range is. If you've forgotten, here's your reminder. So your interquartile range is your upper quartile, take away your lower quartile. Now your upper quartile is the median of the top half of the data, and your lower quartile is the median of the bottom half of the data. So you cut the data in half, so you chop it in half, you have a top half and you have a bottom half. You work out the median of the top half in the usual way. That's your upper quartile, that's the UQ. And you work out the median of the lower half, that's your lower quartile. And then you do the upper take away the lower. So in order to chop these numbers in half, I'm going to chop right down the middle, right through the median. So it's as though, you know, there's a pair of scissors and they've been chopped in half. And so here's your upper half, and here's the lower half. They've been chopped in, it's been literally chopped into a lower half and an upper half. And then for the upper quartile, we look at the numbers in the upper half and we find the median of those. Now that's the numbers 7, 10 and 12. So I would cross off the 7 and cross off the 12, and of course there is the upper quartile. So the upper quartile is 10. And the lower quartile, well, I would cross off the 2 and I would cross off the 3, and I'd be left with this 3 in the middle. So the interquartile range for number 1 is 7. It's 10 take away 3. Now remember, when you are cutting the data in half, you don't include the original median. So you literally cut through that median and then only consider the numbers to the right of it and the numbers to the left of it. And then the actual calculation for the median is then just the usual thing that you would do for the median. Okay, so I'll just quickly run through number 2, 3, and 4. So there we go, that's that one. Might use a new piece of paper because you can see through it. So number 2, we put the numbers in order. So 5, then 10, then 10, then 11, then 15, 16, 20. So that's 7 numbers altogether, and we had 7 to start with, so there we go. So for part A, I would cross these numbers off, starting at these sides and go to the middle, and of course the median is 11. So we actually have we don't have to go halfway between 2 numbers there. There is just 1 number left in the middle. So that's number 11, so that's the median. And then for part B, the interquartile range is your upper quartile take away your lower quartile. Now we need to chop the data into 2 parts, the upper half and the lower half, and we have to cut through this 11. We have to cut through the median. So cut through, gets rid of it, and again I've got 3 numbers to the, like in the upper half, and I've got 3 numbers in the lower half. I do not include the original median. That wasn't really relevant, particularly in the first example, because the median was already something that was halfway between. So you know that the 5 wasn't even part of the numbers to begin with, is what I'm trying to say. So it really is just cutting them in half. But when we have a median that's actually part of the data, like in this situation, you don't include it. Okay, so we still have 3 numbers and 3 numbers. Okay. So your upper quartile is, well, we will go to the median of the top half, so that's 16. For the lower quartile, it's the median of the lower half, so that's 10. And so the interquartile range in this question is 6. Right, number 3. Put those numbers in order. We do have to include the 0. So you can't just forget about a 0. That is a number, it is a data point, and it's the smallest of those numbers, so we have to write it first. So 0, then 1, then 3, then 7, then 10. So for part A, the median is 3. So I'm going to go a bit faster now for answering these. But of course, if you have any specific questions or anything you want to ask, just send me an email. And then for the interquartile range, I need the upper quartile and the lower quartile. So in order to do that, I chop the data in half. I really chop through that original median, so I'm just left with the 2 numbers and the 2 numbers either side. And then if you think about it, if you wanted the median of 2 numbers, you're almost already there. You just have 2 numbers left. So you have to go halfway between 7 and 10 for the upper quartile. So 7 add 10 is 17, and half of 17 is 8.5. So you've got 8.5 for your upper quartile. And then you've got to go halfway between 0 and 1 for your lower quartile. Because if you think about it, we've just been left with 2 numbers in the middle. It's what we started with, but there's nothing to cross off. We just have those 2 numbers left, and we have to go halfway between them to get the median. So halfway between 0 and 1 is 0.5, and that gives us an interquartile range of 8. So that's that one. And then last question in the Bell task is number 4 here. We have to put these numbers in order, and they actually are handily enough already in order for us. So for the median, I'm going to the middle. I have these 2 numbers in the middle, so I have to go halfway between them. So halfway between 0 and 27 is 13.5. And then for the interquartile range, I'm going to chop down the middle, and I'll be left with these numbers on this side and these numbers on this side, and all that's left is to work out the medians. Now I might use this as an opportunity to show you how you would use a calculator to do this. So let me just bring the calculator up. So there we go. So for the upper quartile, so let me just write this down. Interquartile range is upper quartile, take away lower quartile. The upper quartile is halfway between 27 and 38. Now, what I can do on a calculator is add them up, press equals to get an answer, and then divide that answer by 2, and then press the SD button. So that upper quartile is 32.5. And I'm just using this as an opportunity to show you why you need to be careful if you're using a calculator. Because if you do 27 add 38, and then you were to write divide by 2, like this is not going to give you the right answer, because of BIDMAS, this will work out 38 divided by 2 and just get an answer for that, and then would add it to 27. So if I press equals here, you'll see I don't get 32.5. If you were to want to write it all in one line on the calculator, you need to use brackets, right? So that means it's going to do the 27 add 38 first, because it's in brackets. It'll get an answer, and then it will divide that by 2, and that's where the 32.5 comes from. Right, so the upper quartile is 32.5, but what about the lower quartile? So in this question, the lower quartile is the median, which is of these two numbers, so halfway between -4 and 0. So halfway between -4 and 0, I could obviously use a calculator for that, but I can also just work that one out quite easily. That's -2. So the lower quartile is actually -2. And now this is where, of course, you need to remember what happens when you take away a negative. So if you remove negativity, you go up the number line, you feel more positive. If I take away -2, it is the same as adding 2. So you get an interquartile range of 34.5 for this question. Okay, so just be careful about that, because that could come up, and you need to be aware of that. Right, hopefully everyone's done okay on that. Of course, feel free to, once you've seen that, to have a go at some of the Hegarty questions on the median and the quartiles of things. Hopefully now you'll be able to do it and feel quite confident. If not, feel free to send me an email. So I actually forgot to say exactly what we're going to be doing in this video. Now I know that it'll say it in the title, but I'm going to do a very, very brief overview of something called cumulative frequency. But before I actually get to that, I'm just recapping a couple of the things that you need to know, which is median and interquartile range, and then one other thing, for you to be able to have a go at all of the Hegarty tasks for this week. So we also have a starter, just like we would have in class. So I'll read all three of these questions are quite similar. The last one involves algebra, so your answer will be a little formula. But all three questions are quite similar. Question 3 is obviously a bit trickier, so you can just focus on number 1 and number 2 if you want to. Let me just read number 1 out and then explain what I mean, okay? So imagine you've got an ordered list of 10 numbers. Now that does not necessarily mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, it could mean that. That is an ordered list of 10 numbers. But any list of random numbers, like what we had here, I mean, this is a list of 4 numbers in order, right? So this isn't an ordered list of 10 numbers. I'd need 6 more numbers, and then I need to put them in order. The numbers can be anything. I just need 10 of them, and they need to be in order. So that's what this means. And then it doesn't ask you what is the median, because how we don't know what the median is going to be unless we know what the 10 numbers are. right? It depends on what the 10 numbers are, and in particular, it depends on what the middle number is, or what the two middle numbers are. So it's not actually asking you what is the median. It's asking you whereabouts, be specific, whereabouts would you need to go to find the median? So if it's if it's in a specific position, is it the 5th number? Is it the 6th number? Is it halfway between two positions? Like, whereabouts do you have to go? So for example, let's just do it with 3 numbers. So imagine my 3 numbers are 6, 12, and 13. So it doesn't actually matter what the numbers are. This is just with 3 numbers. If I said, whereabouts do you need to go to find the median? The answer is, it's the 2nd number. It's the 2nd number. So for 3 numbers, the median is the 2nd number. What about 4 numbers? So it doesn't actually matter what they are. So I'm just going to put 4 dots, right? These could be any numbers as long as they're in order. Whereabouts do you go to find the median? Oh, it's halfway between the 2nd and the 3rd. So this is what I'm asking you here in questions 1, 2, and 3. Okay? For 10 numbers, whereabouts is the median? For 39 numbers, whereabouts is the median? And if like, what's the rule? What's the rule if I have n numbers? If I have any number of numbers that you want, what's the rule? What do you have to do to work it out? Right, again, I'm going to invite you to pause the video, have a think, get some answers. Even if you just get answers to 1 and 2, that's okay, but have a think about what the rule is. Like, what is it that you're actually doing to figure this out? And then resume the video. Right, I'm going to assume you've had a go. If not, maybe pause after you've seen the answer to number 1. So anyway, in number 1, if we've got 10 numbers, you could even draw a little pattern if you really wanted to. The idea is you try to spot a pattern. Because if I asked whereabouts would you go for 1,200 numbers, you don't want to be writing down 1,200 dots. Like, there is a general way you can work this out. So anyway, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you were to actually cross these off, it will be halfway between the 5th and 6th number. So that's the answer to number 1. Now I could be a little bit more detailed. I could say I could start to suggest what the rule is. I think I might do that. If you do 10 add 1, you get 11. And then if you do 11 divided by 2, you get 5.5. So let me write that down. If I do 10 add 1 and then halve it, that will be 11 over 2, which is 5.5. Now, this is going to tell me that it's halfway between the 5th and the 6th number, because 5.5 is halfway between 5 and 6. So let's see what the answer to number 2 is. So I don't want to write down 39 dots. What I'm going to do is I'm going to say 39 add 1 is 40. And then I'm going to do 40 divided by 2, which is 20. And then that's the answer. It's the 20th number. So 39 add 1 and then divide that by 2 is 40 divided by 2 is 20. It's the 20th number. Now let's have a think about why that might be. You'll have 19 numbers, then the 20th one, and then another 19 numbers. So I'll say that one more time. Think about how many numbers that will be altogether. There'll be the first 19, then there'll be the 20th one, and then there'll be another 19. So that's 19 and 1 is 20, and then another 19 is the 39 altogether. The 20th one was the one that was in the middle with 19 numbers on either side. With this little pattern here, this little rule here, this is actually kind of going to be what gives us the answer to number 3. The answer is you add 1 to however many numbers you have, and then you divide by 2. If the answer is a whole number, then that really is, that's the answer. That's where the median is. If it gives you a 0.5, it means it's halfway between. In the situation of 5.5, it's halfway between the 5th and the 6th. If it was 20.5, it would be halfway between the 20th and the 21st. And so what this is going to let you do, if you can use this little rule here, is answer some of the trickier questions to do with finding the median from a frequency table. Right, I am going to make this a little bit of a longer video today. Normally I would like to keep them shorter than 20 minutes, but I'm already at over 21. We're just going to power through. So if you want to pause and take a little break, that's absolutely fine. Otherwise, just, keep watching. So next slide. So work out the median from this grouped frequency table. So what I'm going to do is I'm going to invite you to pause the video and make a little copy of that frequency table on a bit of paper, and then you can have a go and then resume the video in a second or two. Right, so hopefully what you've got is this table copied down, and if you want a reminder on what a table like this actually means, I'll provide one for you now. So what it means is, and in this picture we're just going to pretend we've rolled an 8-sided dice, and we counted up how many 1s we got, how many 2s, how many 3s, 4s, 5s, 6s, 7s and 8s. Of course this could really be anything at all. It doesn't just have to be the numbers 1 to 8. It could be something more complicated. It could be something even simpler. It just doesn't matter. But in this question here, we are going to pretend it was an 8-sided dice. We rolled it however many times, and let's actually work out how many times it was rolled, right? Like that would be a good idea. So how many times was this rolled? So I'll do 17, add 19, add 22, add 34, add 33, add 18, add 20, add 21. So the dice was rolled 184 total dice rolls. So this is what you get when you add up the total frequency. I've said this many times before in class. What a table like this is actually representing is, now it's not necessarily the order that the numbers came up in. In fact, it's really quite unlikely that for the first 17 throws they were all 1, and then for the next 19 they were all 2, and then for the following 22 they were all 3. Of course they didn't all come out in that exact order, but what's happened is we've put them all in order at the end, right? So we have a 1, 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 and I can't be bothered to do it for these just to show you the point. So 3, then 4, then 5, and then 1, 2, 3, 4, 5. So we've got 17 1s, followed by 19 2s, and this is of course where I started, like, it was already too much to write all of that, but now it's definitely too much. So this is where I put a few dots, right? There are 19 2s, then there are 22 3s, there are 34 4s, there are 33 5s, there are 18 6s, there are 27s, and there are 21 8s. So it goes all the way to the end, and then finally there's an 8. And all together, if I could be bothered, I wouldn't have put the dots. I would have written 184 numbers in a row, right? where the first 17 of them are 1, followed by 19 2s, followed by 22 3s, etc., etc. That information is in that table. And the question then is, well, how am I going to work out the median? I mean, that is literally what the question is. How do you work out the median? So, of course, you can write down all 184 numbers. That's fine. But that's quite a pain. And then imagine if it was even more. What if it was 100,000 numbers? Like, you just would not write them all down. We have to have a better strategy. And so this is where I'm going to begin to introduce something called cumulative frequency. So let's put an extra column on our table called cumulative frequency. Now, cumulative comes from the word accumulate, which means we're building up, we're continually adding something on. We're going to be adding up the frequency as we go along. So in the first box, we just have 17. I have 17 numbers altogether so far, if I just start from the beginning and just include the ones. Then I've got another 19 numbers if I include all the 2s. So 17 add 19 is 36. So basically what it means is you've got the individual scores, and then for each of those scores you've got a cumulative frequency, which means how many are there up until and including those. So if I'm only including the ones, I've only got 17 numbers, but if I go up to the 2s, I've got 19 of those plus the original 17 ones. And that's all we do when we're putting on a cumulative frequency column. So now I would add 22, then I would add 34, then I would add 33, then I would add 18, then I would add 20, and lastly I would add 21, and of course I get 184. Right? There are 184 dice rolls that are 8 or less. There are 163 dice rolls which are 7 or less. There are 143 dice rolls which are 6 or less. These numbers here are telling you how many of those do I have or less. So the 58 means I have 58 numbers which are 3 or less, for example. So now we think about what we learned about just before. Whereabouts will the median be in a ordered list of 184 numbers? So the little formula that I use is I do 184, add 1, and then divide that by 2. So I need to figure out what is 185 divided by 2. It's 92.5. Which means the median is halfway between the 92nd and 93rd. I've just realized the calculator's in the way. One sec, guys. There you go. Median is halfway between the 92nd and 93rd number, because that was the answer. Right? Now, the cumulative frequency helps us to work out whereabouts some numbers are. For example, the first 17 numbers, and in particular the 17th number, is a 1. And then the 18th number is a 2. Right the way up to the 36th number, which is the last 2. And then the 37th number is a 3. And that goes all the way up to the 58th number, which is the last 3. And then the 59th number is then a 4. and that goes all the way up to the 92nd number, which is the last 4. And then the 93rd number is the first 5, and that goes all the way up to the 125th number, which is the last 5. The 126th number is the first 6, and that goes all the way up to the 143rd number, which is the last 6. The 144th number is the first 7, and that goes all the way up to the 163rd number, which is the last 7. The 164th number is the first 8, and then it goes up to the 184th number, which is the last 8 and the last of all of those numbers. Now, I know I said too much there because it was actually enough to work out what the 92nd and 93rd number was. Now, in this situation, we actually have that the 92nd number is the last 4, and the 93rd number is the first 5 in this really long list of numbers. The 92nd number is a 4, the 93rd number is a 5. That is where I would go to find the median. So I go halfway between those two numbers, the 4 and the 5. So the median is 4.5. If the two numbers had actually been the same, then it's really easy. That would just make that number be the median. If they'd both been 4, for example, then the median would have been 4. If they'd both been 5, the median would have been 5. But in this situation, we were literally the last 4 and then the first 5, and therefore the median is halfway between them. So, I'm hopeful that this one example makes sense. Of course, Mr. Hegarty himself has some videos that you can look at as well. I'm going to continue this video. I'm not going to split it into many videos. So again, if you have any questions, of course, I can do more examples, but they take quite a bit of time, and it's not as easy to get feedback through obviously me doing a video. So hopefully that's been okay. You obviously can always send me an email if you've got any questions. So the last thing to talk about is cumulative frequency graphs. Okay, cumulative frequency graphs. And what we're going to do is just look at one example, and I'll explain what the example is. So a cumulative frequency diagram or a cumulative frequency curve is something that can be drawn from one of these continuous, from one of these grouped continuous tables. Okay. Now, these were covered in previous Hegarty tasks. Now, I actually do have a video which I've kind of recorded them slightly out of order, which is a little bit annoying, obviously. But I actually have a video which I will release a little bit later, which recaps these. But unfortunately, I am actually going to have to wait to release that because it's not covered in the thing it relates to isn't covered until next week. But anyway, hopefully you're okay with these tables. Remember, all this actually means is so we've got 120 total frequency. So if I do 8, add 27, add 48, add 31, add 6, I should get 120. So there were 120 boys altogether, and their heights were measured. And then what all this means is there were 8 boys who were between 145 centimeters and 150 centimeters tall. There were 27 boys who were between 150 and 155 centimeters tall. There were 48 boys who were between 155 and 160 centimeters tall, etc., etc. So it just is basically telling you what the heights were between. And what these symbols here are, the less than or equals and the less than that we've got here, they're just there to tell you whereabouts you would go if you were exactly 150, or you were exactly 155, or you were exactly 160, or you were exactly 165. So it's the one with the line in it, which is where you would go. So for example, if you were exactly 155 centimeters tall, so exactly 155, you don't go in this group, you go in this group because of the line here. This group here, the one I'm circling with the mouse cursor, this is all the boys who were between 155 and 160, but it includes all the boys who were exactly 155. Any boy who was exactly 160 would actually find themselves in the next group. Okay, so that's all that's meant by this picture. So what we do in this situation is we to draw a cumulative frequency diagram, we need an extra, in this situation I guess it's an extra row, but what I'll do is I'll copy it out here on this bit of paper and I'll draw it the other way around so that they're columns. So I've got height, so this is 145 to 150. We've got 150 to 155. We've got 155 to 160. We've got 160 to 165. And we've got 165 to 170. So that's kind of the annoying part. Like you actually have to copy that out. And then you've got frequency. So again, I'm just copying those numbers: 8, 27, 48, 31, and 6. And then what we need to do is we need to add on an extra column. The extra column is the cumulative frequency. And this is actually what's going to go on the y-axis. These numbers here, I'm not sure, I'm just going to check if you can see that colour. Yeah, sorry, I'm just dragging that down. Yeah, you can see that colour, that's okay. So these numbers here, go on the x-axis. That is quite faint. I won't use that pen anymore. Let me just write that again. So these numbers here go on the x-axis. So you might want to make a little note of that, because this is going to kind of be how it is for, well, all of the questions that you're going to do, basically. The only things that's going to change is obviously the frequency numbers will be different, and it might not be height anymore, it could be something else, and then these numbers could be different. But this is what goes on the x-axis, and this is what's going to go on the y-axis. So I'll fill the numbers in and then I'll show you how we would draw it, okay? So the cumulative frequency first of all, so that's 8. So there were 8 boys who were less than 150. So this is all to do with being less than. So there were 8 boys who were less than 150. Now I'll do 8 add 27, which is 35. There were 35 boys who were less than 155, right? Because being less than 155, that's these 27 boys plus those 8 boys. Then I've got 35 add 48, which is 83. Right, because 35 add 50 is 85, and then take off 2 is 83. So there were 83 boys who were less than 160. 83 add 31, well, it'll end with a 4, and then 8 add 3 is 11. So there's 114 boys who were less than 165. And then lastly, we now add on the final 6, and that's what brings us to the 120 that we already knew, right? We already knew there were 120 boys altogether. There are 120 boys who are less than 170. So let me just move on in the PowerPoint. So the x-axis is what's being measured, okay? So it's going to go on the x-axis from 145 to 170. I'll draw that in just a second. And then the y-axis, what you'll put on the y-axis is cumulative frequency, and it's how many are less than that particular x. Okay, so the cumulative frequency goes from, well, it's going to have to start at 0, but it goes up to 120. So how should we do that? Should we go up? See, can we go up in tens here? So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, and then that's that. So as I say, what goes on the y-axis is the cumulative frequency. So cumulative frequency, and now I'm just going to double check that you can see that okay in the video. I mean, I appreciate it is quite small, perhaps a little bit dark, but I think it's okay. And of course, remember, Mr. Hegarty himself has questions. Getting the lighting in here just right so that it's okay for the camera is not easy. It's why I'm trying to use obviously these thicker pens. But to draw this graph, I'm going to have to do it like this. So hopefully you can see that okay. So as I say, it goes from 0 up to 120. So that's that part. And then along the bottom, now one thing you may have forgotten, I'll just take this opportunity to remind you, is since it's really starting at 0, but we really want it to start at 145, you kind of put this little zigzag in. And what that little zigzag does is it allows you to start at, like, basically it's saying I've cut a bit out. I've gone all the way from 0 up to 145, but then I'm going to go up in 5s. Like that. So that little zigzag, there, oh gosh, that is really difficult. There you go, there's a little zigzag at the bottom there. Sorry, it's not quite in focus. But there's a little zigzag at the bottom there, and then I'm starting at 145 because these numbers here start at 145. And then as you can see, I've left the same space all the way along. Remember, the numbers go on the lines. That's another thing you need to remember. The numbers go on the lines, and I've made sure I've gone up in equal spaces, going up in this situation in 5s. And so the question is okay, so which coordinates do I plot to then join up? So, I mean, that's what we're doing at the end of the day. We're drawing a little graph here. So what do you do? So one of the coordinates is 158. Okay, so you go to the x number, 150, and then you go up to the y number of 8. So there's 150 on the x. Actually, sorry, I haven't labeled my x-axis here, have I? So I need to write height, and it's in centimeters, right? So that's what goes on the bottom. It's whatever's being measured, okay? So we plot a point 158. So hopefully you can see where those numbers are coming from. 158. So 150 here, and then up to 8. It's just a little bit below the 10. Okay, clearly because of this scale, I'm not going to be able to be that accurate, but I also don't want a really huge graph. So there's pros and cons. So 158 is the first one, and then the next one is 155, 35. So 155, and then I go up to 35. And then the next one is 160, 83. So I'll go along to 160, and then do this carefully. I go up to 83, which is just a little bit above the 80, obviously. And then I've got 165, 114. So 165, and then I go up to 114, which is there. And then the last one is 170, 120, which is there. And so those are the coordinates. And so what you do is you always make sure you plot at the upper ends of these, because it's all the less thans, like the bigger numbers. So these ones on this side, and then that's where you go up to on the y-axis. Okay, that's what you do. And so the only differences that you'll ever really find are obviously the numbers themselves will be different, but that's the method. Okay, now we actually have to end up joining these up. Now I'm just going to double check how what Mr. Hegarty does, because I want it to be consistent with what you're going to be asked about. So he starts it, he does put a little thing there, right? Okay, that's fair enough. So you don't have to do this, but we can put a little, dot there at 145 0. We can put a dot there, and then what Mr. Hegarty does is he uses a ruler to do this. Now I actually on my desk here don't actually have a ruler, so that's a bit embarrassing, but what he then does is he joins all of these up with straight lines. Now that's what you'll find, that's what you'll see on the task, and I'll see if I can get this on the screen now. Right. There we go. There we go. It's on the screen now as we speak. There you have it. So this here is the first of the 2 Hegarty tasks on cumulative frequency diagrams. Now, I'm not going to say anything in this video because it's already extremely long about the second cumulative frequency task. I'll leave that to a little bit later in the week, give you a chance to do the other tasks before you tackle that one. But this is what you'll find in, I believe it's task 437. Yeah, that's right. So task 437. So you are given one of those grouped continuous data tables. So this time it's something in kilograms. So from 30 to 50 there were 2 of them, 50 to 55 there were 5 of them, etc, etc, blah blah blah. And so in order to answer this question you need a extra column on, which is cumulative frequency. Then I will have 2, I'll have 2 add 5, I'll have 2 add 5 add 4, I'll have 2 add 5 add 4 add 8, and then lastly I'll have 2 add 5 add 4 add 8 add 11. And these are the numbers that you go to on the x-axis. So one of the coordinates will be 52, then one of the coordinates will be 55 7, 75, and then I'm not going to say any more. I'd like you to obviously have a go. But yeah, that's how you answer this. And so what you've got in the Hegarty task is some options of what the cumulative frequency diagram looks like. So you either draw these out yourself and then compare them, or you obviously have a think about what the coordinates should be, and then check which one it is out of the options that Mr. Hegarty provides you. Okay, so hopefully all of that's been useful. Well done if you sat and watched the whole thing in one sitting. Obviously that's fantastic, but I will put a little thing in the description that kind of puts some timestamps on so that you can just go back to individual parts of this video. Let me know if you've got any questions. Just send me an email, leave a like, and subscribe to the channel so that I don't have to keep sending emails out. That would be another good thing, because I am going to put videos on here regularly that will help you and will even help you into the future, because I am wanting to keep this going. So this would be definitely something worth subscribing to, and certainly checking every now and again to see if there are any helpful videos for you. Right, thanks very much guys. I will see you in the next video.